So did you see, children? You will find explanations for all those activities in our present topic, and that is nothing but pressure. So in our previous chapter, we learned about force, and pressure is also very much closely linked to that topic. That is nothing but force. So today we are going to learn about pressure. In order to understand pressure, we need to understand few basic terms here, new to you. Let us understand the meaning of thrust. So what is thrust? It is the force that is applied normal to any surface. Say for example, this is the surface, and if a force is acted upon normally, that means making 90 degrees angle, that means straight down, okay? That is to the surface, if the pressure is acted upon normally, at a normal angle, okay, normally, then we call such a force as thrust. The name given to such a force is thrust. It does not mean, say for example, if this is my hand, if I am applying pressure like this, if I am applying force like this, that means this is making 90 degrees angle. That means it is perpendicular to the surface. What am I doing? I am actually applying thrust on my hand. So any force that is acted upon normally, okay, any force that is acting normally to a surface, that such force is called as thrust. And now as per to the definition of pressure, we say that it is the force per unit area. As simple as that. What is pressure? It is force per unit area. When we are talking about force with respect to area, we call that as a pressure. We call that as pressure. In our previous topics, we learned only about force. What kind of force, resultant force, net force acting on a body. But on a body, how much amount of force is acting on how much area will give you the description or will define the pressure that is acting on that body. So did you understand, children? When you are talking about force with respect to area on which it is acting, we are actually describing about pressure. How much of pressure is applied on that particular body. So what is the definition of pressure? It is force per unit area. That is nothing but pressure is equal to F by A. What is the formula? Force per unit area. We know that force, what is the unit of force? It is newtons, or I can say kgs, meters per second square. What is the MKS unit of force? It is kg, meters per second square. Because force is, do you remember what is force? It is mass into acceleration. Mass is kgs and acceleration is, what is the unit of acceleration? It is meters per second square. The MKS unit is kg into meters per second square. Or it is also called as newtons. By what is the SI unit of area? Area usually it is length into breadth, right? So it is meters square. Now we can say that the unit of pressure is Newton per meter square. This is the MKS unit of pressure. Now talking about the SI unit of pressure, it is called as, this newtons per meter square is given a term that is known as Pascal. So the Pascal is the SI unit of pressure. Now let us try and understand the relationship between the pressure and force and area. As you can see that the force is in the numerator and area is in the denominator. So anything that is in the numerator is directly proportional. So we can say that pressure is directly proportional to force. And anything in the denominator is inversely proportional. I can say that it is inversely proportional. It is in the denominator. So pressure is directly proportional to force, and pressure is directly proportional to 1 by A, or I can say this as pressure is inversely proportional to area. So let us try and understand more about it. If force is increased, pressure will also increase because it is directly proportional. When force is increased, the pressure will also get increased. When force is decreased, the pressure will also get decreased because it is directly proportional. However, you change the force, so there will be the similar change in the pressure also. If you increase the force, pressure also will increase. If you decrease the force, pressure also will decrease. But that is not the case with area. Very, very important concepts. What all examples I showed to you in my previous video, this has, explanation for all those day-to-day activities, those examples. Pressure is inversely proportional to area. That means if the surface area of contact increases, the pressure decreases. That is what is called as inversely related or inversely proportional. If one increases, the other decreases. Okay. Now, say for example, if area, the contact surface area is decreased, then the pressure would increase. The pressure would increase. Now that is what, the explanation, this is the explanation for all those examples that I showed to you. Say for the first example, if you see that cutting of any vegetable or anything with the blunt end of the knife. If you see the knife, it has one blunt end and, it has one sharp end. This is the sharp end, right? And this is the blunt end. Now, when compared to the sharp end, the blunt end has more area, right? The blunt end is not as sharp, right? So, it has got wider area. You can see that it has got wider area when compared to the sharp end. The area is more here on the blunt side and the area is less on the sharp side, sharp edge of the knife. And that is the reason. See, when the area is more, what will happen to the pressure? The pressure that you apply, irrespective of the force that you apply, the pressure will decrease. The pressure will decrease. That's the reason why cutting with the from the blunt edge of the knife becomes difficult. Did you understand now? So when you talk about the sharp end, now the area is less. Area is less. That means the pressure will be more. That's the reason why it can really cut through the vegetable or the fruit with less effort. Actually, you can cut the vegetables or fruits. Did you understand? So that's what. And the same thing, the straps of your bag also. When the bag straps are very thin, you feel lot of pressure on your shoulders. That's the reason why the school bags are made with broader straps, so that lesser pressure. Broader straps means more contact surface area, right? The surface area is bigger now. When the area is made bigger, what will happen to the pressure? The pressure will decrease. And that's the reason why what I showed to you. Holding a bag, carrying a bag with very thin straps, it's very, very difficult. You feel a lot of pressure on the fingers. If you put a cloth or anything, if the straps are broader, then you find it more easier to carry. And that's the reason. Because when the area of contact, the surface area, if it is increased, what will happen to the pressure? The pressure will decrease. And for the same reason, the porters carry, they carry heavy loads. And for that reason, what they do, they just keep one extra piece of cloth on their heads. And then on top of that, they put the load. Now they feel it more easier, because without the cloth you will see that very lesser, the contact area is lesser. Only this much is in contact with the big load, and that whole load is acted upon a small area. That's the reason why you feel more pressure. When you put a cloth around on your head, and then it increases the surface area, and because of which the pressure is decreased, they feel it little easier to carry when they just keep a cloth on the head. That's the reason. So here this relationship, how it depends on the area, how pressure depends on force and how pressure depends on area is very, very important, and it gives all the explanation that we need for all these examples. Right, children?